In this video, we will talk about a particular method in optional class called the stream method. We will talk about a few idioms on how best to use this method and integrate with Java streams. But before that, let me give you a bit of an overview of optional. You can also watch my video on fluent programming using Java optional. You see the link on the upper right corner of your screen. Optional was introduced in Java 8 to reduce the number of null pointer exceptions that occur in Java code. Optional class is basically a container for the actual object that needs to be returned by a method. The big idea here is that if a method returns a value which can be null, then that method could instead return an optional with the value contained inside it. In other words, the method will not return a null, but an optional object which has a valid value or an empty. Here are some ways to create optional objects. You can see an optional.off where you cannot actually pass a null. Then you have optional.off nullable where you can pass a null object. If you pass a null object, then it will return an empty optional. Otherwise, it will return an optional with that particular user. You can also create an empty optional using the empty method. The optional class also has a number of methods to consume the value from it. Broadly speaking, we can divide these methods into two types, the imperative style and the functional style. There are methods like isPresent or get, which can be used with a typical if-then-else style of programming. That's the imperative style of programming. More interesting are the functional and fluent style methods. Some of the examples are shown on the screen: the map, the filter, the flat map, or else. One method among them, the optional.stream, seems a little bizarre at first glance. An optional object either has a value or does not have a value. Why on earth would we need to create a Java stream out of it? Let's analyze that a bit more. We know that Java streams programming has been very popular among Java developers. It encourages a functional style of programming and makes the developer's job easy in many use cases which deal with collections. On the screen here, you see an example of a Java stream pipeline. Here, a list of names who have valid addresses are extracted from a list of person objects. Such manipulation of collections is extremely straightforward using Java streams, and it usually involves using the map and filter methods of the stream interface. Just like we can create a stream out of the collection, we can also create a stream out of an optional object. That's exactly what the optional.stream method is about. When the stream method is called on an optional object, it will return an empty stream if the optional is empty. It will return a stream of exactly one element if the optional has a value. At this point, you might be wondering where such a stream can be used. Let me show you an example. Imagine that there is a user class which simply has the following attributes: name and address. We will also assume that the developer returns the optional type for the address because maybe it can be null. Right over here. Let's say we have another class called users, which acts like a factory for the user object. And it has a method called getAllUsers, which returns all the users in the system. The important point here is that this method is returning a list of users so that the Java stream pipeline can be used. It is unimportant what the logic of this method is. We are simply faking the user list over here. Now let's implement the use case to display all of the user addresses if they are available. That means they are not null. Very simple. Now we could do this in a functional style. First, we get all the users by calling the getAllUsers method. We then create a stream out of the list object. We use the map method to get a stream of optional string. Remember that the getAddress returns an optional string. We use the filter method to only look at the addresses which are available, and then again use the map method to extract the address using the get method. Now this guarantees that the addresses are always available before the get method is called. Now this works. You can see the output generated and it does not contain the address for Jack Doe because it's not available. However, a shorter way to do this is to use the Optional.stream method along with the flat map method of stream. In this case, you see that after using the map method to get a stream of optional addresses, we use the flat map method. When we pass the method reference optional::stream to flat map, the flat map will internally call the optional::stream, and it will call it on the optional string object available from the previous map method call. And this results in a stream of string. Now note that we cannot call map instead of flat map here, because otherwise the output will be stream of string. The call to flat map will essentially flatten the stream of string to a stream of string, making life much simpler for us. Now you can also combine map and flat map. As we can see on the right side, instead of using optional method references. You might find this easier to understand. Note that the map and flat map methods are called on the stream and not on the optional object. So final thoughts, many of the Java libraries return optional types as part of their method calls. So it is important that these optional objects can be easily integrated into the Java streams pipeline, which is heavily in use by developers today. Optional.stream method makes this integration possible. Now if you like this video, give a big thumbs up and don't forget to subscribe to this channel for more such material.